Welcome again. Now, today we look on our module 2 of plant breeding, and this one we will deal with the selection methods in crop improvement. We are now undergoing step from module 1. We now want to do about selection methods, and this one is best to get a good improvement in the crop. So we have methods, or which are the methods chosen, and it will depend on which manner. So methods chosen depends on number 1, the nature of the trait of interest, its inheritance, amount of variability present and available, economic factor, and even resource available, and even the resource what available. And this one is when we speak about the nature of the trait. I can use example. Let's speak about, we're speaking about tomato production. Our trait of interest, we'll have some which is good in production, not good in resistance. Again, we can have some having the trait of yielding a lot of tomato, but in terms of the size, small in size. We have those which yield larger size, but few in number. So that is the nature of your trait of interest. Do you want what? Number 2, the inheritance. We'll say you want now to do some gene combination. How will it be about the inheritance? Which one will be inheriting first? So you transfer that which have a good inheritance from the ancestors. Then amount of variability present and available. The amount of what? Variability present. So this one we said our gene of interest was size of our, it was about the size of what? Size of the tomatoes. Then this one is about now variability. He said large, small, variability present. They are available already. Economic factor. For you to do this process, it's not just a one circle process. It will take to around 11 circle process. So it means it's not just a 1 year thing. What will be the economic factor? Then the resource available. If you have enough resources, you can go. We have the inbreeding and we have even the pedigree. So the resource will determine which you will go for. In terms of our plants, cross self-pollination, you can just do that within a short while. But now, in terms of your resource availability, is what will take you on the step to follow. Let's discuss about the pedigree selection. We said we have major selection methods in breeding, where we have types of inbreeding, cross breeding, line breeding. We love the mass selections and the rest, but now here we're speaking about pedigree selection. In our plant breeding, we measure on pedigree selection. So we have F1 to F11. So our first, let's start with the F1. Let me use a good example. We just use an example, not a good example. We can use the one that I said, tomato production. So you will take about 25 to 50 F1 plants. They will be grown and allowed to self-pollinate to produce large F2 population. So we are speaking about 25 to 50 F1 plants are grown. So you just, F1 means it's your first start of your experiment. You go to your nursery bed, take around 25 to 50 seedlings, you plant them, you allow them to get self-pollinated in just a mixed field, and you produce a large F2 population. Those are the fruits now that you will get in your F2. The number will depend upon the parents and the type of cross. The number will depend on what? Number of parents that you have and the type of grosses that you will do. That is your F1. When it comes to the F2 now, they have grown, you have got the seeds. Maybe your interest is about the large size. So you take 100 to 500 plants, space plan, selections are made based on individual and plant genotype. So this is what we mean. You did 25 to 50, right? At the first initial. That's like the parent. Like me, I had my parent, that is my mom and my dad, those are the parents. And they gave me with my other offspring, that is our F1. That is our F1 generation after the parent. So you see that? So we are saying you had a seed and another seed, that is the parents. We got those fruits which had a lot of seeds. We took 25 to 50 seeds and we obtained, after that we obtained now our F2. We take again still 1,000 to 5,000 plants. We plant these 1,000 to 50,000 to 5,000. We select them. Now after that we do selection made of individual and plant phenotype. We are now studying selection, right? When you planted your 1,000 to 5,000, they grew a lot of fruits. Now from this one, we are saying we are doing about selection. And how will you do your selection? Based on the features that we see. If it's our interest was about the large sized fruits, we go for that. That is our plant phenotype. What do we see? Then you take around 5 to 10%. That is what we select. If it was 1,000 and you do by 10%, you'll just take 100. If it's about 5,000, you just take 500. Then you then start keeping records carefully. And we also do something called culling. So because they were 1,000, now because we did 1,000 to 50,000, it means we'll have a larger number, that's to 50,000. So we eliminate and only take 5 to what? 10%. Then this selection is mainly qualitative trait. What do we mean on qualitative trait? We just do the major genes. That is 1 or 2 sides of a gene. Qualitative, main genes. If it's about the size of the fruit or we are dealing with a large, that is what we go for. The rest we do culling. We eliminate them from our process. Let's go to our F3. So from that now, we had said you do what? We had said from our F2, we were selecting around 100 plants. So those seeds of the selected plants are space planted. You give a progeny row of each selection, 10 to 30 plants per row. These are columns, these are rows. So we are saying within these rows, you have around 10 to 30 plants by the row. We are saying you have harvested, you have dried up your seeds. After drying up about the seeds, now those 100 seeds that we have said you have selected based on your phenotypic characteristics and based on the qualitative traits. You do what? You space those plants, you give the progeny row of the selection, 10 to 10 plants by the row. We carry out selection as a single performance, but our emphasis here now, we go to the superior family performance. It's again about selection. You select a single performance, but emphasis placed on the superior family performance. Our superior, you have your one target, and your one target is about fruit size and the yielding. So you now go for that fruit size, which is the large size. Then from that point, we go to a F4 generation. You have completed, you have taken that gene of a superior interest, that is superior family. Now you still have your two families, but you go for the superior family. You take those seeds, you can go and dry up, then your F4 generation. The superior plants now are planted, selected within among the progeny rows. When you speak about the progeny row, progeny is about offspring. So you do some superior plants selected within among the progeny rows. We start reducing now the numbers. We start reducing what? The numbers. And when you go to the advantage and disadvantage, this one will be your disadvantage. We just have limited number. Then you go now to your F5. The previous step is repeated, of which you said, what were we doing? The superior which were being selected, you do within the progeny rows, you plant them, then you reduce the number. The numbers now are advanced, the next level are reduced. It's almost the same with your F4. Then may select best of related lines now. This one now is the difference. This one was family line, but this one is the related line at this stage. And this one is considered as the key selection generation. So the feature of F5 That is your key selection generation. Now from that F5, we have the F6. We do the selection. Then this selection I evaluated as a part of a plot. Within the rows, we are doing it in a plot sections. So we do selection, that is commercial seedling rates. Then the advanced numbers are greatly reduced. We said after stage 4, 5, 6, we are now at 6. We are still greatly reducing the reduction number. Families may be represented by one member of closely related family based on what? The superiority of their genes. Then at F7, further selections are made. And based on this selection, we still do some grade reduction. Then at F8, the 8th generation to 10th generation, we do just a replicated test. We just continue with our replicated what? Test, what we have been doing from the other group. We do it now repeatedly. Then after that, we do evaluation based on observation, and we eliminate the quantitative traits. We are saying we are retaining the qualitative, and we say the qualitative is what? Best of one or set of what? Genes. Best genes. Quantitative was polygynous, and this one was meaning what? It had a lot of characteristics. So we eliminate those with quantitative traits, we retain those with qualitative traits, like quality and yield of different families. Then the last now set on this pedigree, we do one best or more lines. With the one with the best one or more lines are entered into a regional trial. Those with the good qualitative traits, we're saying the best, are now entered to the regional trials. And this one is to confirm if those best genes are retained. So let's check about the advantage and the disadvantage of this pedigree. If you never understood, let me use a simple term of pedigree based on an animal. You have a zebu and you have a Frisian, the male and the female. When they mate, you get your F1 offspring or progeny. Progeny is just offspring. From that point, those F1, that calf that has been raised, it will grow to maturity. When it comes to the mating time, you look again for the Frisian of high quality. From that point now, that Frisian, at the first we have 50% now. That calf will be having 50% phenotypic characteristics of the Frisian, 50% of the zebu. From that point now we go to our F2, and our F2 will be what? F1, that calf, let's say it's the female, mating with another, the Frisian of that high quality, you get your F3. And from this point, the F3 will be having, because of the characteristics of high superiority of the Frisian, it will be having around 70% Frisian and what? These other one, 25, 75, 25 to make it 100. We'll continue that way with this calf giving birth, being raised, it grows, we serve again up to that end, and we are saying that one best or two lines are entered to the regional trials, and you'll have a pure breed, such kind of animal. Let's check the advantage and the disadvantage of this process. The advantage of this pedigree selection, the advantage of the pedigree what? Selection. The first is early elimination of merge materials. We are saying the advantage. Those with the negative traits, we are speaking about the qualitative and the quantitative. Those quantitative traits are first to be eliminated. We just focus on our qualitative traits. So it's an elimination method. The pedigree has an advantage. It has a good elimination method. Number two, the breeder is able to know the great deal about the materials, collect data, and evaluate over a period of time. especially, and this one I'm saying it's only especially when the resources are not limited. When you have enough resources, because going to 11th generation is not that easy. So that breeder is able to know the great deal about the material, collect data, and even evaluate it by recording over a period of time. So this one will be an advantage if the resources are enough. Third, rapid approach of homozygosity. When you speak about homozygosity, is the similarity in the genetic makeup. And this similarity is about because of the qualitative traits being retained. So the rapid approach will give us the homozygosity. Then fourth, can select outstanding lines early in the program. We select the outstanding lines. We say the family which have a good traits, good qualitative traits, are the one that will be selected. And we say the other one are what? Because of the reduction, we eliminate them. The fifth, each selection generation is in different environment. Each selection generation is in a different environment. Hence, we'll have the opportunity to have many genetic characteristics or characters being expressed. Each selection generation is in a different environment. The first environment, the first set. So we are speaking about seasons, right? Let's say this group of ours takes 3 months. Our next 3 months to come, then we plan our F2, will not be experiencing the same environmental factors as it were in the previous one. So maybe we can be experiencing what? Short rains, in the other season, long rains. In the other season, we depend on irrigation. And because of this one, we are saying each selection generation in a different environment. Hence, we'll have the opportunity to have many genetic characters expressed. They will not be the same in short rains. They will not be the same in long rains. They will not be the same when induced to irrigation. And the last one is the process is based upon sequential progeny. We are saying it's based on sequential sequence. F1, F2 to F11. It was a sequential process. So we say the progeny, that is the offspring, are based on sequence. That process is based on sequence of the progenies.